webinar. Here, this is the model I'm going to use for our demo today. This is the Halmatro spreader. All right, so this company makes a lot of rescue equipment for firemen. So this spreader would pry open, jammed doors and things like that. And you can see the assembly's not quite complete. So what I'm going to do is I'm going to toggle to a different display style here so I can really see what I'm working on. The next piece that I need to draw that is missing is this push piece and connecting to this arm. So that's where I'm going to kind of start. I need to draw up a new part. All right, so to start a new part, we'll just go ahead and pick from our list of templates so we get all the settings that we'd like. And then I'm going to pick one of my planes to start sketching in 2D. Now, one of the great things about SolidWorks is all my tools that I use a lot are just a mouse gesture away, so I don't have to go searching for them, do a lot of window washing or toolbar hunting or menu diving. I can just gesture to all my favorite commands, like maybe my circle command, and then from there maybe to my line command. Just one more line and we'll finish this guy up. And you'll see at the moment my sketch is free to grow and change, but it grows and changes according to the relationships that I've already established. All right, now I'm going to go ahead and start keying in some of the known dimensions that I'm looking for. And as I'm doing this, I want you to watch the color of my sketch. It's going to slowly change from blue to black, letting me know where I've got definition and where I'm still missing it. Okay, you can see, again, my circles are still free to change. Here, I want to go ahead and grab both of them at the same time, and then I can choose from a list of different relationships that make sense for these two circles. Okay, we'll give them an equals relationship. All right, next, we'll go ahead and key in the last couple dimensions. And finish this sketch off, and then we'll be on to our first feature. All right, so now that I've got my 2D sketch drawn up, I can start selecting the contours that I would like to extrude out or give material to. So we'll grab these two, and then I can use my on-screen ruler to snap to. We can even add a little more intelligence to the model on the fly. Like here I want symmetry. So I can go ahead and key in symmetry right away. All right, next if I want to round off these edges, go ahead and start up my fillet command and then use the new on-screen gesture to help me find similar edges that I would like in my model. And notice how I grabbed all my concave edges and then added a fillet on them right away. Now I didn't know what fillet size I wanted, which is why being able to play these dimensions right on the model is really helpful. You can see I want this fillet to go all the way to that bottom edge, and now just by dragging and pulling on it, I can find that dimension and get it to the right size. Okay, here I was looking for 30, and we can key that in. All right, next. I can now start sketching right on the model. Now that we have geometry and space, we don't necessarily need the planes. Here I want to go ahead and split this tab into two. So we'll go and gesture to our favorite rectangle tool. Again, snap to the existing model geometry. And then we'll key in our one missing dimension. All right, now we want to go ahead and cut into the model. And again, we can use our on-screen ruler to get the depth we're looking for. In this case, maybe 40. I'll be able to change that later if I'm not sure I like 40. And then we'll round off these internal edges. So again, now I can use the on-screen selection tool to get the edges I want. And then we'll key in our value of 2 and enter. All right, now we're ready for our last boss here. Again, we'll just gesture our sketch tools, key in some values, and we'll go ahead and extrude this out. All right, I'm almost done with the model, but now I need to start tapping some threads onto this. Okay, that way we can thread it in into our final assembly. Okay, and we'll start with our hole wizard. Now, hole wizard is a really nice, handy tool. Basically, it's the machinist handbook built into the software to save you time, so you don't have to look up for the specs of a number 14 countersunk screw. You don't need to know that anymore. You just tell it where you want your holes to go. Okay, I'm going to snap one right there to the center of our shaft. And then I can pick from a range of different hole types. Again, countersunk, counterbore. We'll go for a tapped hole. Pick our standard. And then we'll pick the type or the size of hardware we're putting into the hole. All right, and you can see that even adds some annotations here in 3D so I can locate the hole, know that it's tapped, see the thread depth and things like that. And then I want to do the same thing on the outside. Okay, we're going to have some external threads on the model. Really no need to actually apply those cuts. Okay, we can just pick an edge, tell where it starts from, pick our standard. And notice it automatically grabbed the correct thread size. It can read the geometry and figure that out on its own. So we'll just add our in condition. We want the threads to go all the way up to that face. Except chasing threads all the way up to that face is going to be pretty impossible. So what we'd like to do is use an undercut here to make that a little easier to manufacture. And now I draw undercuts all the time, okay, maybe once a week. So instead of drawing it every time, I can save an undercut I did in the past into my library. Okay, and then later I can drag that library feature back out. So I can do this with notes, annotations, features, parts, all kinds of things. Here you can see that undercut is a little big for this model. Well, I can create new sizes on the fly. Okay, we can try out 2. 2 looks a little small. I'm going to stick with 4. And so there we got a pretty complex feature in right away with just a quick drag and drop. Okay, and now I'm going to go ahead and chamfer some of those hard edges we need to get rid of. We'll throw a chamfer here and then over here as well. Okay, now I've got the geometry I like. But now that I've got this modeled up, I'm realizing it's a little long. Well, I can edit dimensions as if I was creating them for the first time. Okay, even after the fact, I can go back in time and make those changes, and you see everything updates appropriately. All right, next, I want to go ahead and assign my material. By doing that, it's grabbing all the mechanical properties of that material, like density, modulus, Poisson's ratio, and now I can start running simulations and other evaluations to make sure my part is meeting my requirements. Here, I definitely want to try to keep the mass at a minimum since the fireman has to carry this up flights of stairs. If we can minimize mass anywhere, I want to go ahead and do that. Now that I've assigned this part some material, I can see the current mass in grams. We could come do some custom settings on the fly if I want to see it in inches and pounds instead. Okay, so it's just under 2 pounds. Fairly heavy piece. Maybe we'll try removing some extra material here in a second. But what I actually want to do right now is go ahead and save my model and then document it. All right, so I'm going to go ahead and save this into my protected vault. Okay, make sure I'm keeping track of all the information that I would like to, like descriptions, maybe part numbers. All right, and then we'll go ahead and get that saved. Now here's a handy new tool, Enterprise Pdm. It's keeping track of all my files. It's also forcing me to fill out certain information, like a part number. Okay, it's really important to my documentation process that we keep track of this data. Well, I can make sure that my company's standards are always being met. Okay, this tool will even double check that that's a unique part number so that I don't have any conflicts down the road. And we'll go ahead and add some of the other metadata. Maybe we're going to build this part. It doesn't have a revision yet, things like that. And we'll go ahead and save that into our vault, and then we'll start our drawing. Okay, I even have drawing templates. This will help set up, again, units, drafting standards, and of course that title block at the bottom of the page. But what you're going to notice here, once I drop my views onto the screen, it'll auto-project and it'll auto-populate my title block. So you can see documenting this part is really quick and easy. It already put in my name, the date, the title, description, weight, material. All this information gets populated automatically to, again, help save the user time. We don't want you spending time making drawings. We want you spending time designing, making changes, adding intelligence into your models. All right, next, I probably want to do a section view, something like that. Again, even that's really quick and easy. Just a couple clicks on the screen, and we can get that information. I'm going to put a more detailed thread call out later, so we'll delete that for now. And then maybe we'll finish this off with a detail view. And again, just a little extra annotation cleanup. And then that's ready to go. Now let's import our dimensions. So in no time at all, I'm going to have this fully defined drawing, and I'm ready to move on to my next design task. Get out of the drawing nice and quick, make it easy. I'm just going to hit OK here, and a majority of the work's done now. Again, it's pulling all these dimensions from the model itself. So again, I'm modeling with my intents in mind, so right away I get the dimensions I want for my drawing. Okay, again, I just got to clean it up and make it look nice. That's my only goal. Again, maybe get rid of some dimensions that we'll put elsewhere. Maybe get rid of some dimensions that don't make sense in certain views. And again, trimming back annotation lines is just a quick little drag and drop. Okay, we can clean those up, make them look nice. All right, I don't want to spend too much time here, so we'll call this good. But I do want to get in my chamfer dimension and then my hole callouts. Well, chamfer dimension, I just tell what I'm looking for, grab two edges, and there's that. And then now to my hole callout. And again, even in the drawing environment, I can just gesture from task to task. Okay, here we'll just grab that tapped hole, and you can see it builds out the note with tons of detail for me. And then now I'm pretty much done with my drawing. Maybe I want to give this a little bit of depth by giving it some shading, something like that, and we'll call it good. We'll save this into our vault. Okay, we'll add a description, go ahead and save it, and then it'll pull up the data card as well. So again, I should be keeping track of a lot of this information. Again, maybe the drawing number is the same as the part number or something similar. And again, we'll call that good. All right, now actually before I leave this drawing, I want you to keep track or make a note of some of the information here. Okay, like our hole distance is 50. Well, if I jump back to my model, just click here and change this to say 45. Okay, notice the model updated here. I switch back to my drawing. It's instantly updated as well. If I make a change on my drawing, maybe I change it to 40 here. All the views let me know they're out of date. I want to rebuild. And now notice that they've redrawn themselves. They're all up to date. If I go back to my model, he's already 40. All right, so everything's dynamic. Everything's updating each other in that fashion. Okay, but now we want to insert the rod into our assembly here. Okay, well, what I can do is just get to where I can see both. Okay, I can use my new toggle buttons to help quickly tile my windows. And then if I drag this from one window to the other, he automatically snaps and jumps into place. If we go ahead and maximize our assembly, you'll see that the rod end is already following one of the degrees of motion I'm looking for. And now I just want to make sure I get this edge, and we also want to thread it up to that face. And now he's already made it into place. All right, my next step is to go ahead and start adding in the hardware to pin all this together. Now, in a previous spreader that I've done, I made a link to connect the arm and the rod, and I'm assuming that that same link is going to work for me here and now. So this time, instead of searching for a command, I might search for a certain file inside of my vault. Okay, if I go ahead and do a quick search for my link, I don't remember what it's called. I just remember that it is a link, and we put that in the description. Well, SolidWorks will search through all the metadata in the file, so you don't need to know part numbers. You don't need to know file names. You just need to know something about your part, and SolidWorks can find that file with the search. But an even better search command might be my enterprise Pdm search. Okay, if I come in here and run either a quick search or a complete search, I can get into even more depth. Essentially, I can use that data card we saw earlier as a means of finding metadata that I do know. Again, like maybe a part number, a title, a description, I can search for any of this information. So I remember description, I'm going to say link, and then we'll go ahead and execute our search. Okay, some other nice enhancements here is once it finds all those files, and you saw how fast that was because it is a SQL database, it can search lightning fast. Okay, I can even come in here and select these parts and then try to get more information about them, make sure I'm getting the right one. Okay, so I can look at version data, who's working on it, which ones have been released and which ones haven't. Okay, all kinds of stuff. All right, so here if I go ahead and expand out my preview, which will certainly be helpful, we can find the exact link we're looking for, and there it is. So now I'm going to kind of push my search off to the side, and we'll drag and drop our link into the model. Okay, he also wants to snap into place. So notice my link is already good and ready to go in the one hole, and all I need to do is drag it and drop it above the other hole, and those holes will snap together. And now my new rod end is actually doing the work that it's meant to be doing. Okay, that search also brought up my link pin, which is pretty handy. I also want to put one of these components into this hole. He snaps into place. Okay, and I even built a little property manager here because we use 30 different sizes for our link pins. I don't remember their part numbers either, but I know what diameter I want, so I can come in and put in 22. I know what length I want, maybe 30. Oh, doesn't look like 30 is long enough. Let's try 50. All right, there's what I want. So 50 looks good. I'm going to go ahead and hit OK. Okay, now on to my Toolbox library. So this is the first thing I'm doing that comes in a level above SolidWorks standard. So everything's been standard so far. Now the Toolbox requires SolidWorks Professional. But if you get it, now you get the whole library with every standard imaginable. When you get in there, you get all types of parts, bolts and screws. If we looked in this bolts and screws, you see different screw types, screw sizes, styles. And then if I open this, I've got every diameter and every length imaginable. So a very big, very complete library of hardware. Okay, what I want is an external retaining ring. And we'll just get the basic external ring, drag it into our model, and as I jump from diameter to diameter, it's actually auto-sizing. Okay, some of those diameters are way too big, so you can't tell, but there it's going to auto-size to my link pin and snap into place. And next, I need to put in the same parts again 2 more times to these holes. All right, so I can go ahead and highlight them and then tell it to copy those parts and then copy my mates as well. Okay, I want to be concentric to this hole and then flat on that face, and then concentric to this hole, flat on that face. And now I've got 2 instances in there, 2 additional instances in just a couple clicks. They're already made it into position, so I don't need to move them or change them, but these pins are not quite the right size. Well, I can come grab a shorter size. Oh, too short. Try that one more time. Maybe go for that 40 long, and there it is. So even if I have to work with multiple sizes, I can toggle those on the fly very easily. Now what I need to do is get all the other instances of this part to the other side. I'm going to go ahead and grab them on the screen, grab a plane of symmetry, and then run my mirror command. Notice it shows me a preview of all of my parts. I even get to try different orientations about how it mirrors to the other side, whether it flips it, jogs it, keeps it the same, or actually does a real mirror. And then if I need a hand version of that part, there's a left-hand version and a right-hand version. There's no symmetry. I can have it automatically create that opposite hand version. So you only need to draw one half of your, or one side of your part. So it'll do the other side if necessary. In our case, it's actually not necessary. But if it was, we could do it with just one click of the button. All of these are completely reversible or flippable to the other side, so as you can see. All right. Okay, now we've got our full range of motion in here, and notice my arms are coming together perfectly. Well, that's because I knew what dimensions I wanted, but let's test out what would happen if we still had an incorrect size in here. And notice now I'm putting my assembly through the full range of motion, and the arms aren't quite coming together. So there's a very easy design mistake to make. And if we didn't catch that in time, that could be really costly. But now that I'm building this virtual prototype, if you will, I can go ahead and test out the design, and I can find that mistake early. I can even start pulling up my measurement tool, start figuring out how far apart these jaws really are. Coming up with that distance, maybe a center to center or minimum distance across holes. Or maybe I'm looking for more of an angle. I can come in here and find that the angle between my arms is still 21.5 degrees, so I need to figure out a way to close it. Well, notice I can make these edits directly in the model, or directly on the model, but in the assembly environment. And again, any change I made, just updated my drawing. All right, now that we've got all our parts in, let's go ahead and bring all the components back, and then maybe make an assembly drawing. Okay, so that's going to require an exploded view. I've already started my exploded view, but all those new parts that we added, obviously aren't in the exploded view yet, so we need to edit it. Okay, all I got to do to create these is just add parts, and then pick which direction I want to pull it. Y direction arrow in the Y direction. Okay, we'll grab these parts, and we'll fan them out, pull them off to the side. Grab our links and pull those out. And then our retaining rings last. Pull those down. Okay, so it's that fast to create an exploded view of parts. Okay, now that we've got that, we can go ahead and, update our assembly. Maybe rebuild and save it real quick. Start an assembly drawing. Okay, just like the part drawing, this is a really quick, easy final step. I'm going to drop my views on, create my bill of materials, my table, put in some balloons, and then I'm done. So just like before, we get a preview of all of our views ahead of time, and then when I drag and drop them out on my screen, I can automatically propagate to the other, or project to the other view types. And we'll go ahead and throw in an isometric view of our assembly as well. In here, I'd like to maybe have some color, some shading to that. And one quick checkbox, I can activate that exploded version of this view, activate that on my drawing, getting ready for those balloons to come in. Next, I'd like to show the motion of my mechanism as well. Well, I can save a version of it in the closed position and a version in the open position, and then I can tell my view to show both positions. Just an alternate position view. We could pick again, from our open position configuration, and it lays both of those on the drawing. Okay, I can even measure those angles and things like that. If we turn on our dimension tool, and maybe we're looking for the overall size of this, but then we also want to let our users know some angle jaws can open. Again, just illustrating a little more information about our assembly design. And now for the really important part of our assembly drawing, that bill of materials. Keeping track of part quantities, costs, things like that. I want a nice indented BOM, with some good numbering here. We'll hit OK. And you see I get quite a big BOM list here of parts. And keeping track of all the quantities for me, all that metadata from the data card and from the title blocks of those parts populates right into the drawing. And again, we could have part numbers in here as well. Okay, now I actually don't want all those components in here, so I'm going to change this to a top level BOM only. It truncates that down a little bit, and then we'll throw in our bill of materials. Or I'm sorry, our balloons. And our balloons are going to automatically link to the bill of materials. That way BOM IDs match my balloons. And it automatically stores. Okay, we could try a range of different positions, styles, layouts. Okay, maybe we want most of these balloons on the top, on the side. Okay, I'm going to go all around though. All right, we'll hit OK. But now our new magnet tool, I can come quickly grab that whole group of balloons, put them in a slightly better position that makes more sense for my drawing. Okay, we could even pull balloons off of magnets and snap them to other magnets. Or maybe it makes more sense to have those. And then again, we'll slide these in as a group. All right, so now that my assembly drawing is done, we'll go ahead and save this into our vault. Hold on a second, I accidentally forgot an option to not save these read-only documents, so it's going to go ahead and ask me to save all of them. Just going to hit no. So that was a checkbox I should have had on, and it would remember its setting next time, so I wouldn't have to do this again. Just bear with me a moment. Once I got all this set up, we're going to realize that there's been a design change. So I'm not the only engineer working on this spreader assembly. In fact, chances are at your office, you're not the only engineer working on any given project either. So I've been finishing the assembly, as you saw, doing the rod end and the connection to the arms. Well, another engineer has been working on the handle assembly, and I think they've come up with a new design. All right, where are the Y's? Almost done there. And just to show you again that when I go to save something, there's an option to not save read-only documents. I should have had that on, but oh. All right, so now I'm going to kind of get into my vault view here off to the side. Okay, and it's giving me a lot of information about all of these parts. Okay, right here it's showing me who's working on what. I can see which files I have ownership of. I can see which files are still a work in process and which ones have been released. Which ones are actually out already in production. Okay, if I'm going to make any changes to a production part, I got to copy it, make a new part number, or I've got to get approval for a new revision of that, things like that. So it kind of controls the workflow that way. Okay, now I can see here that my handle is not necessarily up to date. And actually, let's jump back over to our model here. Like right now, the handle, I've got this old version, local version's old. There's been newer revisions since that. I can see Rev 3 here. We're already up to version 3. So with a quick right click, I can say get latest version. And again, normally in a multi-work environment, it would have the other user over here, John or Tim, whoever's working on that handle. And then I would see what version he's just put into the vault. So I get that notification. To get the newest version, I right click and just say get latest version. Okay, it's warning me that it's going to need a rebuild, things like that. I can go ahead and say get it. Do I want to go ahead and replace this in my model? Yes. Okay, and now it's actually thrown in a new version of that assembly. Okay, but now let's see how the workflow goes when I go to check this back into my vault. So right now, I'm the one with the master copy of this assembly. I've put things together. Now I want to put it into the vault and submit it for approval. I'm thinking the design's done. So as far as I'm concerned, it's done. I want to go ahead and send it through the approval process. So again, I'm going to go ahead and save this into my vault. Tell it do not save read-only documents this time. Okay, so it doesn't have to bug me to save copies of all those parts. Okay, but I get that notification about this new handle. All right, now I'm going to go ahead and pull up my vault, or my vault view here. Let's close this folder. Okay, so here's Enterprise Pdm. So this is not something that you have to set up, but I highly recommend it. First thing you'll notice is the interface is actually just Windows Explorer. Okay, you already know how to use Enterprise. It's just like Windows. You just come browse into folders, find your parts, find what you want to work on, and open them. But with some special nuances. Okay, the folder icon will look different color, different icon. letting me know I'm in the vault. And when I get into a vault, it'll have read and write controls as well as a bunch of other rules. So you can go through every employee at the organization and say, tell the vault what they're allowed to do and what they're not allowed to do. So that way your data is protected. And once I get in there and find the data, I can select it and view it. Okay, I can see who created it, when, part numbers, gather all that metadata without having to have a license of SolidWorks. I also don't have to know where the drawings are stored, or if I'm a salesperson or I'm in ordering management, I'm outside of the engineering group, I can still come in and get the data I need to do my job without bugging the engineers and without messing with any of the engineering files. I can just select them and view that data myself. And now here, if we grab that handle assembly I mentioned earlier, we can see there's the 3 versions. I can see all the metadata I want, add to the metadata, again, without having SolidWorks. Get a bill of materials to see what I need to order, for, as far as quantity goes and costs and vendors, and get all that info to place my orders. And then even preview the document. Now you can even load in a 3D view or 3D preview of this document if you'd like. And that's what it's doing right now. So your non-SolidWorks users would even be able to open up models, rotate, view them in 3D, make sure they're ordering the right parts and looking at the right documents without the dangers of ruining any files. All right, now I've got all these files checked out, as you see. But again, I think they're done. So what I want to do is check them in. And I want to post a comment, for my manager. And again, notice I'm getting warnings about files being open, things like that. So I need to come back over here to SolidWorks and close these. It would warn me about, lots of things that that I want it to make sure I'm following the right workflow and not making mistakes. All right. Yeah, so I'm going to go ahead and again, Windows, select my parts, and do a batch check-in here. And I'll give my comments, or actually I'll post my comments in here in a second. All right, so now I want to bump these through the workflow process. Again, right now they're a work in progress. So what that did is it hid the files from everyone outside engineering. Again, they shouldn't know that these files exist yet. They're still a work in progress. It also controls who can edit them and things like that. But now I want to change their state and submit them for approval. Okay, now I'll post my comment. Again, please review, design, and add comments. Let me know when it's approved. And then I can pick which project manager to notify. I can even come in here and go, hey Suk, please look at these files. All right, so now it's been bumped through the workflow. Different read and write controls have been implemented on those files. Now engineers aren't even allowed to make edits to them. The edits are temporarily frozen. If my manager, the project manager, if he doesn't approve the files, they go back to a work in progress and then they're editable again. So again, this really kind of controls the workflow and really makes things easy and transparent, and again, helps you get that control and that consistency. So now, what I'm going to do is I'm going to go ahead and log off as Brendan. Okay, so again, I'm now going to log back in as the manager. So again, all he needs to do when he gets into the office in the morning, he fires up his email. He already got that notification. Or he comes into the vault and just logs in. Okay, so he puts in his credentials, hits log in, and then you heard that noise and he gets a little pop-up. He instantly got notified about these changes. Okay, you can see the files, view them, you know, again, look at different things that have happened, different notifications. Here's my notification. Please review design, add comments, let me know it's approved. Okay, and I can close that. Now let's say the manager's job is to, you know, or project manager sends it over to the analysis team or something like that. And now we want to verify that that handle is going to hold up for strength purposes. And then if it does, then the design's approved. Now, we could run the analysis right here on this file. So, you know, again, here's the second handrail. I can preview it to make sure it's the right one. And now that I got it, I can open it up. And notice it's even asking me, do you want to check it out? I could say yes if I want to save my changes, and I probably would want to save my simulation data. But I can also say no, I don't have to check it out unless I'm planning on saving changes. So I can just come in and then run the analysis. Now I'm running the Express version, which comes free with all the versions of SolidWorks. In fact, all of these Express tools do. But there's a much larger suite of simulation tools. You can test your design to make sure you're getting the right motion, power input, power output. You can test fluid dynamics around your model. You know, if you have heat transfer or aerodynamics or pressure problems. You can test for strength, fatigue, vibration, heat, all kinds of different things, drop tests. Now I'm just going to run a quick static, you know, stress test. That's all I'm going to do, but you know, just because of time's sake. But we've got that whole range of products, that whole suite of products. And so I'm going to come in and pick my units, hit next, and so I have this little wizard that's kind of walking me through things. You know, in case I'm fairly new to simulation, it just kind of holds my hand, makes it really easy, makes it make sense, you know, for a novice user. But then if I get the full version, I'm going to get a lot more options. So, you know, again, that advanced user has what he needs as well. Okay, so here again, I'm getting a little animation about what a fixture does, and you know, again, it makes sense now that I would want to fix my holes. Those are where it mounts to the rest of my assembly. Okay, and then I'll hit next. So it's kind of walking me through this checklist. Now add a force. I want to apply it to that handle, and I want it to be normal to plane 1 here. Okay, we want to reverse the direction, and then maybe we give it, I don't know, 300 pounds of force. And I'm on to my next step. Yeah, it's pulling all those mechanical properties from the material I already chose. But if I wanted to try other materials, I could do that. Okay, you know, maybe I want to test out 6 different materials before I decide to go with the cheapest one. Again, try to save costs. But then if I like my setup, I go ahead and run it, and then in a matter of seconds, I get a nice detailed plot and information back about how this thing performed in the real life. Okay, I could try out multiple loading scenarios, multiple load values, different materials, different dimension values. Maybe I want to play with thicknesses. And then now that it's done, okay, I get an over-exaggerated look of the deflection to make sure it looks accurate. And then you can see all the areas of my design that did not meet my factor of safety of 2. Okay, so we definitely have some stress problems that we might need to solve. If we look at our plots, look at our stress concentrations, we're getting the highest kind of right along that bar where we would expect. And I can see it's actually yielding the material. So we're definitely in trouble. We need either a stronger material or a thicker dimension to really help this last in the real world. So it did not pass the design. I'm going to go ahead and close this though, and no need to save it. But now I can come back into my vault and then either approve it or not approve it. So again, I'm going to change the state, and again, if it had passed, maybe I would go ahead and release the documents, but if I reject the changes, okay, I could let Enterprise know why, or let my user know why. Again, I could tell it to notify my engineer, my designer. He gets the notification right away or the next time he logs in. And then he knows to go back and redo the design, make it correct, make it accurate. So that obviously was not every tool in SolidWorks, but that was a good introductory look at a lot of the really commonly used tools. Again, interference detection, hole alignments, and all these things to make sure your design works. So being able to test the form, fit, and function virtually here, and then run through a lot of iterations in a collaborative environment using ePDM, we can get our jobs done a lot faster, and our designs will be a lot better. So that concludes my presentation. I hope you enjoyed it. Again, sorry for the confusion earlier about our start time. I appreciate you sitting through all of it, and again, we'll try to get this recording online as soon as we can. And thanks again. Hope to see you on Thursday for our Enterprise PDM webinar, where we'll dive into more detail about that Vault tool that we offer. So again, take a look at all of our webinars coming up at mcad.com. We'd be happy for you to join more of those. And thanks again, be in touch, and we'll see you next time.